You've likely heard it, or maybe even said it yourself. A storm is coming. I can feel it in my bones. It sounds like folklore, an old wives' tale passed down through generations. Yet, for many, the sensation is undeniably real. An ache in the knee, a stiffness in the fingers, a throb in a long-healed fracture that seems to precede a change in the weather with uncanny accuracy. This isn't a trick of the mind or a lucky guess. It's a complex biological response to an invisible, powerful force that is pressing down on you at all times. You are, in a very literal sense, a walking barometer, and your nervous system is reading the atmospheric data. To understand this internal forecast, we have to look smaller, at the microscopic sentinels embedded within your tissues. These are called mechanoreceptors, specialized nerve endings that respond to mechanical stimuli, like pressure, vibration, and stretch. You have them all over your body. They're what allow you to feel the texture of a surface or know how hard you're gripping a cup. A specific type, baroreceptors, are exquisitely sensitive to changes in pressure. While they are famously known for regulating blood pressure inside your arteries, similar sensory nerve endings exist within your joint tissues. They are the biological transducers, converting the physical force of the atmosphere into electrochemical signals your brain can interpret as sensation, or in this case, pain. The air around you has weight. At sea level, it exerts about 14.7 pounds of pressure on every square inch of your body. Your body is accustomed to this, pushing back with its own internal pressure from fluids and gases, creating a state of equilibrium. But when a low-pressure weather system approaches, that external weight lessens. The column of air above you is lighter. This subtle change upsets the balance. With less force compressing you from the outside, your body's tissues can expand ever so slightly. Think of it like a very, very mild version of what happens to a marshmallow in a vacuum. This expansion is microscopic, far too small to see, but your nerve endings can certainly feel it. So, why is this sensation localized in your joints? Because a joint, particularly the synovial capsule, is a relatively enclosed, fluid-filled space. The synovial fluid within provides lubrication, but it also means that the pressure changes are amplified in this confined system. As surrounding tissues expand, they press on this capsule, changing the pressure dynamics inside. In a healthy joint, this change is negligible and goes unnoticed. However, in a joint that has experienced trauma, arthritis, or inflammation, the story is very different. The internal landscape has been altered. After an injury, your body heals by creating scar tissue. This tissue is less elastic and more disorganized than the original tissue. When the pressure drops and tissues expand, this rigid scar tissue doesn't stretch as easily. Instead, it pulls and tugs on the surrounding structures. Critically, these areas of chronic inflammation and scarring are often populated with a higher density of sensitive nerve fibers. The microscopic stretch, amplified by the inflexible scar tissue, is just enough to irritate these nerves, sending a pain signal to your brain. Your weather knee isn't predicting the future. It's reporting on a present physical reality that your other senses miss. This brings us to the element of prediction. The pain often arrives hours before the first raindrop falls. This isn't precognition, it's a matter of meteorology. A storm is a complex event, but it is typically associated with a zone of low atmospheric pressure. This low-pressure system is a massive weather feature that moves ahead of the clouds and precipitation. Your body isn't sensing the rain, it's sensing the drop in barometric pressure that is the precursor to the rain. It's detecting the cause, not the effect. The invisible front line of the storm passes over you first, and your sensitive joints are the first to report its arrival. While barometric pressure is the primary driver, it's rarely the only factor. Weather is a system of interconnected variables. A drop in temperature, which often accompanies a storm front, can increase the viscosity or thickness of the synovial fluid in your joints. Thicker fluid means more friction and stiffness, compounding the discomfort. Changes in humidity can also affect the way your tissues, particularly scar tissue, expand and contract. The sensation you feel is not a response to a single data point, but an integrated perception of a changing atmospheric environment. What this ultimately reveals is that you are in a constant, dynamic conversation with your environment, and most of it happens below the level of your consciousness. The ache in your joint is a form of perception, just like seeing or hearing. It is your nervous system translating the language of physics into the language of biology. We navigate the world with our 5 famous senses, but our bodies are collecting countless other streams of data: pressure, temperature shifts, humidity, perhaps even electromagnetic fields. The pain is simply a signal that is loud enough to cross the threshold into your conscious awareness, a bulletin from a sensory world you are perpetually immersed in, yet rarely notice.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.